Here's how you do number 4 on the lab that we did, the potassium chlorate and sugar lab. This is an example, another example of Hess's law, how to do it. Now with Hess's law, what we're doing is we're trying to find the delta H, or the change in enthalpy, for that equation right there. But we've got a couple of equations, actually 3 equations here. We're going to combine, we're going to add them together to figure out what delta H is. So we're just going to go through them one by one. The important thing to remember is if the reactants and the products are on the same side as the first equation, and is there the right amount of the reactants and the products. So if we look at this first equation, we have C2H2 gas right here on the left side of the equation. Over here it's on the right side. There's no O2 in the equation, I'm not going to worry about that. There's no CO2 in the equation, I'm not going to worry about that. And there's, if we look right here, there's no H2O either. So we're going to look at this C2H2, and it needs to be on the other side. So we're going to take this, equation down here, and we're going to reverse it. We're going to rewrite it. So the reactants, so we're going to write 2CO2 gas plus H2O liquid. Goes to make C2H2 gas plus 5/2 O2 gas. And our delta H, since we reverse the reaction, we have to reverse that sign. So it's going to equal to a positive 1,229.5 kilojoules. Now we're going to go to our next equation. We've got carbon on the left side and carbon on the left. We've got O2 is not in there and CO2 is not in there. So it's on the left, but you notice there's 2 carbons here and there's only 1 right here. So we're going to take this whole equation down here and we're going to double it. So now we've got 2 carbons plus 2 O2s goes to make 2 CO2 gas, and our delta H, we're also going to double our delta H. So our delta H now becomes 787 kilojoules because we had to double that. The next equation, we've got H2 on the left and H2 on the left. We've got no O2s and no H2O. So that equation right there, we're not going to do anything to. We're just going to leave it the same. Now what we're going to do next is we're going to look at everything that's on the left and the right. If they're the same on the left and the right, when we add them up, we're going to cancel them out. So if you look right here, we've got 2 CO2s on the right, 2 CO2s on the left. So we're just going to cancel those out. The other thing too is if we look right here, we've got 1/2 O2 and we've got 2 O2s, which actually becomes, if we add 1/2 and 2, it becomes 5/2. And on this side, we've got 5/2 O2s. So those 5/2 O2s and those O2s are all going to cancel out. Then what we're going to do, and one more thing, sorry, also we've got 1 water on the left and we've got 1 water on the right. And now we're going to just add everything together. So we've got right here, we've got 2 carbons. How's that supposed to be a solid? It's supposed to be an S, not a gas, an S. Plus we've got H2 gas. And that's everything on the left side of the equation equals on the right side. The only thing we have here is C2H2 gas. Now, if we look, this equation has to match up to our first original equation up here on the top, which it does. That means we did it right. And then what we're going to do is we're going to take those 3 right there, and we're going to add them together now. And that, our delta H, when we add those together, our delta H becomes 156.7 kilojoules. And that's how you do number 4 on